Hello all, welcome to our Avirat classes YouTube channel. I am Amol sir. I will take a new topic, that is nothing but the rotational dynamics. So here we will see today the applications of uniform circular motion. In last lecture we have covered the different types of motion, or what is the uniform circular motion, what is non-uniform circular motion. So now today we will see the application of uniform circular motion. Okay, the heading is application. So first application is vehicle along a horizontal circular track. Means suppose car is there. Car is having the circular track and it is moving towards it. So whatever the force will act over there, we will check. In the terms of theoretical as well as practical, or we can say derivative type, right? So again you can have here figure, this is the curved road, and suppose let's say, try to understand, this is car only. So just consider this car is moving along this horizontal track. How? Circular track. While taking the circular track, we know that we will what we can say, we consider one type of external force, that is nothing but again centrifugal and all. Same case, when car is there, of course their tires will be stick to the road. So at that time there will be normal reaction acting. Always remember, the normal reaction will be perpendicular to that car. Let's say car is like this, so its normal reaction will be upwards. So here I have written N for normal reaction. And one more, vertically downward there is mg. Of course the car will carry some weight, so it will, due to gravity, it will move downward mg. Another one force is the centripetal force. It is acting towards the center of the circular track, Fs, of course. So now consider the equation. This mg can be balanced by n. So I have written mg is equals to n. Equation number 1. Similarly, Fs is there, but car is not going inside. Of course, there will be some another force, that is centrifugal force, mv square upon r. So I have written Fs is equal to mv square upon r. Or in terms of omega, we can write mr omega square. Equation number 2. So from equation number 1 and 2, we will get this equation as Fs upon n is equal to v square by rg is equal to r omega square by g. We will require this equation further one. But what is Fs? Fs is nothing but frictional force applied. Okay. So Fs, we can say Fs is directly proportional to normal reaction. Okay. If we take the constant will be coefficient of friction. Means whatever the road we have, that tire and road, that surface will give us a coefficient of friction. So from this formula we can write Fs upon n will be mu s. Okay, and similarly we have equation Fs upon Fl. By comparing this 3 and equation number 4, we will finally get Fs max upon n is equal to v square max by r. And finally v can be calculated as a mu s rg. This formula we will require when we will have some numericals and horizontal circular track. Okay. So another one example is well of depth, moth ka kuwa we can say. In that there is cylindrical shape and two-wheeler motor vehicle will just move through that cylinder. Why it is not falling downwards? It should carry some minimum velocity, right? So that minimum velocity, how much velocity should be there? That velocity we are going to calculate today, right? So consider one cylinder is there, of course Mothko is well is there, let's say, and one motor vehicle is continuously moving, let's say. Of course there is point mass. Again there will be weight, that is mg, vertically downward. And remember one thing, students, I have told you about that a normal reaction, it will always lie as a perpendicular to that. So here the motor vehicle will be like this. So perpendicular to that will be n here. And whatever the surface contact, we can say, suppose vehicle is there and this is cylinder. So vehicle will be like this. So whatever the contact between that wall and the tires of vehicle, there will be the frictional force Fs. And from here you can see Fs and mg equal to, I have written somewhere. Equation number 2, mg is equal to Fs written, and again n, normal reaction. Normal reaction is balanced by mu square upon r. If you consider this equation number 1 and 2, and again frictional force Fs is less than or equal to mu s n, it is always less than. So if we put the value of n over here, mv square by r, we will get the equation, mm will get cancelled, and finally we are having equation of v square. This is nothing but the minimum velocity required by that vehicle driver to keep, so that it will not fall to that well, मौत का कुआं we can say, so rg upon mu s. On this numerical, on this topic we are having one numerical. So numerical is motorcyclist is undertaking horizontal circle inside the cylindrical wall of well the inner radius of 4. So radius is given as a 4 meter over here. Coefficient of static friction between tire and wall is 0.4. And what is the question? What is the minimum speed and frequency necessary? So unknown is V minimum and M minimum. So of course the formula is V minimum is equal to under root Rg upon mu s. So what is the value of R here? It is 4. G is nothing but consider as a 10, and value of mu s is 0.4. If we calculate this, 4 ones are 4, let's say, and the answer will be around, and under root of that we will have the answer as a 10 meter per second. Another one unknown is what is the frequency, rotation per second. Let's say we know that omega is equal to 2 pi n, right? Omega can be written as, that is, we can have V is equal to R omega. So omega will be V upon R. So this formula V by R is equal to 2 pi. But we are interested to calculate n over here. So n will be equal to V upon 2 pi R. V upon 2 pi R. So value of V is 10, 2 pi R, R will be again 4. So by calculating all these stuffs, we will get the value of n as a 0.4 rotation per second. So this is just one numerical. There are more examples are there for practice. You can just go through it, and if you are having any doubt, you can ask me. In further lecture, we will again have few numericals and some theoretical topics. Okay, thank you student. Now we will stop here.